Hey everyone, and welcome! Today, we're going to peel back the layers on something that is absolutely critical to the future of AI. And no, it's not some flashy new algorithm or a super fast new computer chip, it's the very language that our data speaks.
So let me ask you this. What do you think is the biggest thing holding AI back right now? You're probably thinking, well, it's got to be computing power, right? Or maybe we just need smarter algorithms. But what if I told you the real roadblock, the real bottleneck, is something we almost never talk about, something hiding in plain sight?
So here's what we're going to cover. First, we'll look at what I'm calling the AI data dilemma. Then I'll introduce you to a really elegant solution called TOON. We'll get into exactly how it's different, how it could totally unlock AI's future, and, the most important part, why any of this should matter to you.
All right, let's dive right in. Look, to build these incredibly powerful AI systems, we have to feed them just enormous amounts of data. But the way we structure that data, you can think of it like the grammar our computers use, well, it's really starting to show its age. It's becoming a massive bottleneck on performance.
I mean, think about it. Formats like JSON or XML, they're absolute workhorses. They've been powering the web for decades, right? But here's the thing. They were designed for a totally different era, for a different set of problems. They were never, ever built for the insane scale, the speed, and the complexity that modern AI needs. They're quickly becoming that hidden problem that just slows everything down.
And you can really see the difference here. Just look. On the left, that's your typical data in a format like JSON. See all those brackets and quotes and commas? All that visual clutter? It works, sure, but it's super inefficient for a machine to chew through when you're dealing with billions of these things. Now look at the right. That is the exact same data, but in tone. It's just clean, it's intuitive, it's designed to be fast for both people and computers. See how all those extra symbols are just gone? That's not just about looks. That's a huge part of the speed boost.
And that, my friends, brings us to the hero of our story today, TOON. And listen, this isn't just some minor update. It's a fundamental rethink of how data should be structured, built from the ground up for one purpose, to serve the needs of artificial intelligence.
So what exactly is TOON? Well, simply put, it's a new way to organize data. But the most important part of this whole definition is that phrase, designed specifically for AI. Every single decision that went into building it was about helping AI models learn faster, understand more complex ideas, and just run more efficiently than they ever could before.
Okay, so let's get into the weeds a little bit and see what really makes TOON such a potential game changer. It's not just one magic bullet. It's actually a combination of a few really smart ideas that work together to solve this whole data problem.
So what makes it tick? First off, it's incredibly efficient. It uses a way more streamlined syntax, which means smaller files and less data to shuffle around. It's also, and this is huge, actually human readable. If you're a developer, you know what a lifesaver that is when you're trying to fix a bug. It's also super flexible, so it can handle those really deep, complex relationships that modern AI models need. And finally, the whole thing, from top to bottom, is just optimized for pure, raw processing speed.
And you don't have to take my word for it. The numbers here tell a really clear story. When we talk about parsing speed, that's just how fast a computer can read the data. TOON is in a completely different league. File sizes, they're minimal, which saves a ton on storage and network costs. But honestly, the most important column here is the last one. Is it AI native? See, the others weren't. They were adapted. TOON was born for this.
So what does all this technical stuff mean for the big picture? Well, a better data format isn't just some tiny improvement. It's more like we just invented a better blueprint for building skyscrapers. All of a sudden, entirely new kinds of buildings become possible.
The first thing you'd notice? Way faster AI training. When your data is just easier and faster to process, the time it takes to train a massive AI model just plummets. We're talking about training cycles that used to take weeks, now taking days, or what took days might now take hours. That saves an incredible amount of time and, frankly, a lot of money.
This speed boost also unchains developers from the old limitations. It means they can start designing and building way more sophisticated AI models, with more layers, more complex connections, the kinds of models you need to tackle huge challenges in science or medicine, things that were just too clunky to even try before. And this is where it gets really, really exciting. A better data blueprint means AI can finally represent and process more complex, more subtle, more nuanced information about the world. And that leads to way smarter apps. AI that doesn't just spot patterns, but one that can actually begin to understand context. Now, I know this can all sound a little abstract and technical, but a fundamental shift like this is going to be felt by pretty much everyone. So let's bring this home and talk about what this means for the real world.
So, what's the bottom line? Well, for developers, it means less banging your head against the wall and more time for actual innovation. For businesses, it means getting more powerful and cheaper AI tools out into the world. And for the rest of us, it means a whole new generation of AI tools in our daily lives that are smarter, faster, and more helpful than anything we've ever seen before.
You know, it really all boils down to this one idea. A data structure isn't just a box you put information in. The right structure doesn't just store information, it actually unlocks the potential that was hiding inside it all along.
And that really just leaves us with one final big question to think about. For so long, we've had to design our ambitions around the limitations of our tools, around the barriers in our data. So what happens when that barrier just goes away? What incredible things will we build then?